Hello students. Today we will do electric field intensity due to multiple charges. So electric field intensity due to system of charges or due to multiple charges. So now in the system we have n number of charges. It is similar to the superposition principle that we have applied for the Coulomb's law. So in the system, so let us consider a system. In a Cartesian coordinate system, we have charges, say Q1, whose position vector is R1. Now this is similar to superposition principle. Similarly, Q2 charge having position vector R2, then Qn having position vector R. Now we need to find out the electric field intensity, say at point P. So if I need to find out the electric field intensity at point P, I will name its position vector as a R vector. So if you remember, in the Coulomb's law we have found the force acting on charge Q2 due to system of charges. Here Q1, Q2, Q3, Q4 dash Qn all are the source charges, and we have to find out the electric field intensity at point P due to n charges in a system. Now we know the electric field intensity at any point due to single charge. So we give the symbols now like this. E1 vector, R is a function that will give you the position vector of a point P. So if I keep a test charge here, test charge is always taken as a unit positive charge. If we assume all the charges are the like charges, this test charge will be repelled due to the source charge Q1, and the direction of the repulsive force is away from P, and we name this electric field intensity at as E1. So how I will read this E1R electric field intensity at point P, whose position vector is R vector, due to Q1 is, now what is the formula? K source, distance between test and source. So if I keep this arrow here, if you remember, this distance can be written as R minus R1 mod Q, and here it is R vector minus R1 vector. So this is electric field intensity at point P due to Q1. Similarly, electric field intensity again at point P due to Q2. Now source is a Q2 charge. So K source. Now distance between test and source. So I will join this. This point test charge will be repelled away. So this is E2. And this distance will be referred as R minus R2 upon mod of R minus R2 Q. So it is similar to superposition principle, only the difference is here we are using the formula of the electric field intensity, there we were using the Coulombian force. Similarly, the force acting on point P due to nth charge is equal to K source, which is Qn R minus Rn upon mod of R minus Rn mod Q. So here you have to remember, and if I have to join this, join the point, this will be named as En. Remember, in electric field intensity, the subscript indicates the source charge. So if I say E1, the source is Q1, source is Q2, source is Qn, because we know the intensity is of source charge, and to test the intensity place a test charge there. So intensity किसकी होती है? सोर्स चार्ज की. So 1 2 3 dash 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 n will give you the source charge. Now I want to find out the resultant electric field intensity. So resultant electric field intensity at point P, so ER is equal to E1R plus E2R, where this bracket indicates that electric field intensity is a function of the position vector of the test charge plus dash 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 En R vector. Now if I substitute all these values here, this can be written as KQ1 like this. So I am directly writing this as summation K QI R minus Ri upon mod R minus Ri cube, where I is running from 1 to n. So this is the electric field intensity at any point due to the system of charges or due to multiple charges. So this is how the electric field intensity is defined for a point charge which was only K source, distance between test and source, and mode of Q. And now this is the superposition principle. So this is electric field intensity due to multiple charges. Now let us move to example 1.6. Now what is the example 1.6 of our textbook? That we have the three charges whose magnitude is Q, and they are placed at the vertex of a triangle, and the triangle is an equilateral triangle of length L. So this is an equilateral triangle of length L. The charge placed at all the vertex have the same magnitude, that is Q. So let the charge placed at A is Q1 is equal to Q. Charge placed at B is Q2 is equal to Q. Charge placed at C is equal to Q3 is equal to Q. So 1, 2, 3 is the symbols we are using, but the magnitude of charge is same. So given is Q1 is equal to Q2 is equal to Q3 is equal to Q. So these are the three source charges which are kept on the vertex of an equilateral triangle. Then at the centroid, that is denoted by point O, we keep a capital Q charge. So it is given that capital Q charge is placed at the centroid of the triangle, and the sign of this charge is same as that of the charges kept at the vertex. So if we take the charges on the vertex to be positive, the charge at the centroid is also positive. If we take this as negative, the charge on the centroid is also negative. Now how to find out the resultant force on plus Q charge? The question is, find out the resultant force on the charge capital Q. Now how to deal with such numericals? So first thing is, let us check the geometry. It is an equilateral triangle. So from figure, I can say AO is equal to BO is equal to CO, the distance between the centroid and the source charges. So I am referring this small q as a source charge and capital Q as a test charge. And we know while applying the Coulomb's law, we need a distance between test and source. So distance will be AO, BO, CO. Since the triangle is equilateral, AO, BO equal to CO, let us denote this by small r. Now, let us find out the direction of the forces acting on plus Q charge. So this is plus Q, this is plus Q, there will be a force of repulsion. You have to find out the force on Q. So A will repel Q in this direction. So direction of the force will be AO. We denote this force by F1. Similarly, charge B or the charge at vertex B will repel this charge also. So I denote it by F2. Similarly, the charge on C will repel capital Q at the centroid. We name it F2. So the first step was, from the geometry we found the distance, or we have given it R. Then we find out the direction of all the forces acting on the test charge. So here we have three forces, F1, F2 and F3. So F1 is a force acting due to charge at A, F2 is a force acting at capital Q due to B, F3 is a force acting at plus Q due to small q at C. Now the next step is, we write the magnitudes of these forces. First we write the magnitude, the directions are different. Or you can also find out first the distance between the vertex, each vertex and the centroid. Now how to find out this distance AO, BO and CO? So next step is to find out the distance AO, BO, CO. So I am drawing this diagram again. This is my point C, this is my point A. The distance between A and C is the length of the side of a triangle. I draw a Cartesian coordinate system in such a way that point C comes out to be at the origin. Now since this triangle is an equilateral, so we refer this angle between AC and BC will be the 60 degree. So this is 60 degree. I need to find out AO, BO and CO. So I am doing this exercise to find out the distance. This is our point B. Let me draw a perpendicular on BC and name it T. And suppose this point is our centroid O. So this diagram is redrawn like this. Now this angle is 60. So if this is a length of the side of a triangle, I will resolve it into two components. Since I have taken this angle as 60, I drop a perpendicular on this axis and another perpendicular on this axis. Suppose dropping this perpendicular, so we know that it makes an angle 60, so this will be L cos 60 degree. And similarly, the another perpendicular component will be L sin 60 degree. So AD will be equal to L sin 60. It may be possible that we may take this angle comes out to be 30 degree because this is a right angle triangle. Now if I take this as 30 degree, so again resolving this into two components, this can becomes L cos 30 and this component becomes L sin 30. Now you can see that it makes no difference whether I take 60 or 30, because L sin 60 will be equal to L cos 30. So you can take angle 30 or 60. I have taken an angle 60 degree and resolve AC into its two components. Now from this diagram, we write AD is equal to L sin 60 degree. So this AD is parallel to this side. So it is L sin 60 degree, which can be written as root 3 by 2 L. So I found AD for this triangle. So this is our point A. Now, from the geometry, we know this distance AO is 2/3 of AD and OD distance is 1/3. So for an equilateral triangle, or from geometry, AO is equal to 2/3 of AD. The ratio is 2 by 3 is to 1 by 3. So AO is 2 by 3 AD and OD is equal to 1 by 3 AD. We have found AD. We don't require OD, so we are leaving that thing. I need AO. So AO is equal to 2 by 3 AD. AD is root 3 by 2L. 2 cancel, 3 root 3, 1 root 3 is cancelled. So I get L by root 3. So this is my AO. Now we have written AO is equal to BO is equal to CO and we named it as R. So So this is equal to BO is equal to CO is equal to R. Let us name this equation 1, this is our equation 2, and this value of R is L by root 3. So first we have found the distance between the test and source. Now the next step is, you see the steps how we have to do this numerical. So the next step is, write the magnitudes of force. We know the direction is different. So while applying the superposition principle, we have to consider the directions. But first, another step is only write the magnitude. So suppose I write F1 vector magnitude. So it comes out to be K source test charge and distance between source and test, which is OA, which we have already found. So F1 can be written as KQQ upon AO square. Similarly, if I write F2 vector mode, it will be KQQ upon BO square. I am simply applying the Coulomb's law. So from Coulomb's law, now this can be written as, in the place of AO, I can write L by 3, it is AO square, so it becomes L square by root 3, so it becomes KQQQ upon L square. Similarly, 3KQQ upon L square. Similarly, F3 is equal to KQQ upon CO square, that is 3KQQ upon L square. So first we found the magnitude, and we see that the magnitude comes out to be same. So I will write the next step like the mode of F1 is equal to mode of F2 is equal to mode of F3 is equal to, let us name this as mode of F dash, and its formula will be KQQ upon 3KQQ upon L square. Let us name this as equation number 3. So this magnitude of the forces comes out to be equal. So you have to understand the steps we are doing. First we found the distance between test and source. So it was not given. So with the help of the geometry we found this distance. Then we simply applied the Coulomb's law in scalar form, means we are taking the magnitude. And we found that the magnitude comes out to be equal. Now the question is, find out the resultant force on capital Q, which is kept at the centroid. Now let us see about the direction. Now F1 vector is equal to, now this is the magnitude and I am writing F1 vector, so 3KQQ upon L square. And if I see the direction from the diagram, it is along AO vector. A से O की तरफ है, so along OA vector. So now I am writing Coulomb's law in vector form, that is with its direction. Similarly, F2. So again, magnitude is same, direction along B to O. So along BO vector. Similarly, F3. 3KQQ upon L square along C से O की तरफ. So this is now in a vector form. Applying the superposition principle, we know the force acting on centroid, let us name it F0. So it will be equal to F1 plus F2 plus F. This is what we have to find. This is given in the question, that find out the resultant force. So now you have to consider the direction and you have to apply the superposition principle, which in vector form I have written. Now if I see the diagram, the directions are different. Now I have to apply the law of parallelogram, and at a time I will add any two vectors. I can add F2 and F3, or 1 and 2, or 2 and 3, and I have to apply the law of parallelogram. You see this direction we have already written. Now, suppose I first add F2 and F3. So the angle between F2 and F3, again by geometry, this angle comes out to be 120 degrees. So this angle is 120. Similarly, if I apply, if I add 1 and 2, then angle between 1 and 2 is also 120, 1 and 3 is also 120. So it makes a circle of 360 degrees. So first I will find out the resultant of F2 and F3 by the law of parallelogram, and we know that their magnitude is same. So from law of parallelogram, the resultant of F2 vector and F3 vector is given by, now let us find out the resultant of this. So we know this formula, that if you want to find out the resultant magnitudes, so let us name this as F double dash. F dash is for their magnitude, so this comes out to be under root magnitude. I am finding magnitude. F2 square plus F3 square plus 2F2 F3, and what is the angle between this two forces? 120 degree. So this is cos of 120 degree. Now this is equal to under root. Now F2 F3 magnitude is taken as F dash. So F dash square plus again F dash square plus F dash square, cos 120 is minus half. So cos 120 is minus half. So 2 can cancel. F1 dash square, F1 dash square, that will also cancel. So you are left with only under root F1 dash square, that is again F dash. So this is the resultant of, we name this as F double dash. The resultant of F2 and F3 comes out to be same as F2 and F3, that is equal to 3kqq upon L square. So see what is happening. The magnitude of all these three forces is same, and when I find the resultant of any two force, it also comes out to be same. Now this is in the scalar form, that is its magnitude. Let us write this in a vector form. So F double dash is equal to 3kqq upon L square. Now I have removed this magnitude sign. Now where will be this resultant? This is the resultant of F2 and F3. So it should be exactly between this. So this is F double dash, and in the form of the direction, it is opposite to F1 vector. So along F1 vector was written from A to O, this is from O to A. So this is the resultant of F2 and F3. Now if I substitute this value, or if I take the direction OA as r cap, if I denote O to A as r cap, so what this equation turn out to be? Now F naught, now that was our previous equation, the resultant which we have to find, that was equal to F1 plus, now the resultant of 2 and 3 is denoted by F double dash. Now let the direction from O to point O to point A is r cap. So we denote the direction from O to A as r cap. Then F double dash is equal to 3qq upon L square, and the direction is from O to OA. So this can be written as r cap. Similarly, let us talk about F1. So F1 is equal to 3kqq upon L square. Now its direction is from A to O, opposite of this. This is from O to A. So opposite of this. So I give minus sign r cap. Now if I substitute this both values in this equation, then the resultant comes out to be 0. Therefore, F naught is equal to 3kq capital Q small q upon L square. Now within bracket I am using this. So this is minus r cap plus r cap, which is 0. So F naught is equal to 0. So what is the resultant force acting on the charge at the centroid is 0. So this is what how we have to do such sums. This is the resultant of 2 and 3, which was added to F1. So I have first added 2 and 3. You can add 2 and 1. So resultant comes out to in this direction, opposite O to C. Now this O to C will be opposite of CO. So F3 will be opposite of the resultant of F2 and F1. Again the resultant comes out to be 0. So the resultant force acting on the centroid is 0 when all the charges are the like charges. Now the another shortcut method is, let us see the direction of these three forces. So the direction of F2 is this, the direction of F3 is this, and this is the direction of F1. If you remember the vectors in standard 11, if I can form a closed loop from this 3 vector, then the resultant is always 0. If all the vectors form a closed loop, then the resultant is always 0. So let us see how I can form a closed loop. Now take up this vector. Without changing the direction, I draw this F2. Now I take this F3. Let us draw here. This is my F2. I pick up this F3 and place it here without changing the magnitude, whatever length we have drawn. So this is our F2. I have not changed the direction. This is F3. I have not changed the direction. I pick up this F3 and keep the tail of F3 on the head of F2. Now I take F1 vector and I put its tail on the head of the third vector, that is F3 vector, and head on F2. Now if you see this, tail head, tail head, tail head, this is called, the 3 vectors have formed a closed loop. So if the 3 vectors, not necessarily 3 vectors, if there are n vectors and they form a closed loop, the resultant is always 0. So no need to do such calculation for MCQ. First you find out the direction in the diagram, and if it forms a closed loop, then your answer should be 0. So if I have 4 forces, say F1, F2, F3, F4, suppose this is like this. So again you see F1, F2, F3, F4. Head, tail, head, tail, head, tail. It forms a closed loop. So the resultant of all these forces is 0. So if there are n forces acting on a particular point, and if they all form a closed loop, then no need to use this method. Simply the resultant should be written as the 0. The force acting, the resultant force is 0. So this is how we find out the resultant force on any charge.